Crash Course Instrumentation, Saturday Special, From Sparks to Systems, A History of Sources and Loads. Welcome to another Crash Course, Instrumentation, Saturday Special. Today we're dialing back the years and tracing the history behind two of the most fundamental concepts in any electrical system, the source and the load. It may seem simple today. One part provides power, the other consumes it. But understanding how this idea developed gives us incredible insight into everything from early telegraphs to modern-day industrial systems. The birth of the source. Long before we had power supplies and wall outlets, the very idea of a source of electricity was mysterious. In the 1800s, scientists like Volta, Faraday, and Ampere laid the groundwork. Volta gave us the voltaic pile, the first true battery, by stacking zinc and copper plates separated by brine-soaked cloth. This wasn't just a cool chemistry trick, it was our first practical source of steady, controlled electricity. Before that, we were zapping frogs and generating static electricity with glass rods and fur. The voltaic pile sparked a revolution, pun intended. Suddenly, inventors could power devices consistently. This led to breakthroughs like the telegraph by Samuel Morse, and later the incandescent bulb by Edison. In 1831, Michael Faraday discovered electromagnetic induction, laying the foundation for electrical generators and transformers. His experiments showed that moving a conductor through a magnetic field created current. This changed everything. Now we could generate power without chemicals. By the late 1800s, Thomas Edison and Nikola Tesla were battling over how best to distribute this power, DC versus AC. The result? Massive growth in infrastructure, and the modern idea of a source feeding a network of loads. Loads emerge. What do we power? Of course, a source is useless without something to power. Enter the load. Early loads were basic, incandescent bulbs, primitive motors, and galvanometers. As technology advanced, so did our demands. Heaters, vacuum tubes, relays, radios, and eventually televisions and computers. In every case, the load transforms electrical energy into some other form: heat, light, sound, or motion. As loads became more complex, designers had to think more carefully about voltage levels, current demands, and power ratings. Overcurrent protection, fuses, relays, and later circuit breakers became essential. Even in early industrial control systems, you saw this balance: control panels with massive contactors and relays, glowing panel meters, and loads that had to be carefully matched to prevent dangerous failures. The role of instrumentation. As loads became more complex and sensitive, we needed tools to measure and control the flow of energy. Enter instrumentation. One of the most iconic devices in early electrical instrumentation was the Simpson 260 analog multimeter, first introduced in the 1930s. With its rugged design and high impedance, it became a favorite among technicians and is still in use today. The Simpson meter could measure voltage, current, and resistance, and helped generations of techs validate source-load relationships, check continuity, and troubleshoot faults. Later came the digital multimeter, DMM, offering more precision and greater safety features. Brands like Fluke, Amprobe, and X-Tech brought handheld instruments to every technician's toolbox. These tools didn't just make measurements. They helped visualize what was happening between sources and loads. Was there voltage at the load? Was current flowing? Was there an unexpected voltage drop due to wire resistance? Instrumentation became more than a passive observer. It became the gateway to understanding system behavior. What it means for us, the source-load relationship is the foundation of everything we do in electrical and instrumentation work. It's in your loop diagrams, your multimeter readings, your P&IDs, and your wiring schematics. Understanding the history isn't just a curiosity. It reminds us that every circuit is a system of balance. Every device has its energy footprint. Every measurement tells a story. Whether you're designing a control panel, verifying loop voltage, or logging system current, you're tracing energy from the source to the load and back again. It's a dance that started with zinc and copper and continues today with solar panels, variable frequency drives, and smart instrumentation. Want to learn more? This Saturday special was based on Section 5 of the open source Model PDF, https://ibiblio.org, Kuphaldt Socratic Model Modar Source Load. PDF big thanks to Tony R. Kuphaldt for creating these incredible open learning resources. We've come a long way from the voltaic pile. But every circuit still tells that same story. From source to load, energy moves, and we follow it. Thanks for watching Crash Course Instrumentation.